Okay, so let's take a look at this word problem, which is still dealing with linear equations. And I know you guys don't like word problems, but generally they are straightforward if you take your time and try to diagnose the problem very well. So here, let's take a look at this. We're going to solve this in two ways. One way is to plug in, which is a different level of plug in from what we have done so far. Uh, but I'm going to take you through that process. The other way is to look at it from the algebra sense. So let's take a look at this from the algebraic point of view. Now, we were given Mary and Jason. So I think they gave us Jason's age as X. Even if they did not, you always want you to take X or Y or the variable to represent the one with the lower age. So here we have Jason and we have Mary. So Jason is X. If Jason is X today, that means Mary is 2 times X because they say it's twice. So we have Mary as 2 times X. 10 years ago means minus 10. If this is 2000, we are talking of 1990. If it is 2018, we are talking of uh, 2008. So 2008, Jason will be X minus 10. Mary's age will be, her current age is 2X minus 10. But what happens 10 years ago? 10 years ago, this person was 3 times as old as it. That means if we multiply this guy's age by 3, it should be equal to this. And that is all you got to do, like that. Yeah, 3x minus 10 is equal to 2x. So you go back to your solution and look at which of them satisfy the requirement. At times, the solution they probably will simplify, but in this particular case, it was straightforward. So your answer choice is D, straightforward. You just have to set it like this. Now, let's move to the different level of plugin I was talking about. When you get these problems, I will also recommend that don't worry about doing the algebraic aspect because I just want you to understand, as a student of mathematics, to at least to be able to do algebra. But for SAT and those kind of exams like ACT, what you do is you say, look, I'm going to take a particular value to represent Jason's age and see which of them will work for X based on the information given to me. Now, you got to be very careful as you pick because if you take 10, you notice that, you know, 10 will make these things dissolve. It will mess you up. So take some number that is realistic. It could be 5. So let's say we say Jason is equal to 20 years old today. That means Mary should be 40 years. The question is, which of the equation will give me uh, uh, the left side the same as the right side when I plug in the value of s is equal to 20. All right, so let's do that. So let's say we start with A. When x is equal to uh, 20, we have 40 minus 10 is equal to 40 minus 10 is equal to so okay, let's start with this. So here I'm going to do A first. So we're going to get 2 times 20 is equal to 40 minus 10, that's equal to 30. 30 is equal to 3 times 20, that's equal to 60. So obviously it cannot be A. Let's try B. B is equal to 20 minus 10. That gives me 10 is equal to 20 times 3 is equal to 60. 60 minus 10, that's 50. So obviously it's not this. Let's try C. C will give me 3 times 10 is equal to 2 times also 10. See, so 30 is not equal to 20. So now let's try D. When x equal to 30, let's try 20. So I have 3 times 10 is equal to 2 times 20 is equal to 40 minus 10. This is 30 is equal to 30. So the only equation that will support a given value of x is that one. So remember, when x is 20, you should satisfy both equations. And that is why D is still the answer choice. So instead of going through the arithmetics of linear algebra, you can also plug in your own numbers. So remember, the plugins are two now. You take their own answers and give it back to them, or you create your own answers and use that to find the answers. So we'll be doing more of this plugin as we begin to look at more complex problems. So this is a good way to solve such equations that probably are difficult to even put together.